Hello everyone. This time we'll talk about degree of a polynomial. So our objective would be more on identifying the degree of a polynomial, but we will also do classification of polynomials according to the degree and the number of variables. So try to observe the following. So this is one way to determine the degree of just a term. So we'll just have one term first. So if we have a monomial 5x to the power of 4, the degree is 4. If we have the monomial 4x squared y cubed z, that's a monomial and it has a degree of 6. And if it is negative 5ab cubed c to the power of 5, it has a degree of a 9. So how do we easily determine the degree of just one term? Okay, that's correct. So if you notice here, it's not difficult because the variable here is just an x and the exponent is a 4. So automatically that's a 4. Here, we have three variables. Okay. How did we get 6? The exponent of x is 2. The exponent of the y is a 3. And the exponent of the z is a 1. And you will just have to add them. So 2 plus 3 plus 1, that's a 6. Okay, how about the 9? How did we get the 9? There are three variables. The exponent of the a is 1. Exponent of the b is 3. The exponent of the c is 5. So add them, 1 plus 3 plus 5, that's a 9. So let's determine the degree of each monomial. So again, we're just dealing with one term or a monomial. So the degree here is 6. Because the exponent of the x is just a 6. How about number 2, 3/4? So the degree is 0. Because you don't see any variable. It's just a constant term. So automatically the degree is 0 for that. For every constant term. How about number 3? 6x squared yz cubed. Okay, that's correct. It's a 6 because 2, the y has an exponent 1. So 2 plus 1 plus 3, 6. So again, how can you determine the degree of a term? Just a monomial. It is just the sum of the exponents of every variable in that term. Now, if we know already the degree of one term, so if we do it one term at a time, we can already arrange the polynomial whether it's in descending or ascending order. So when we say descending, from highest to lowest. So here, we're given with 1, 2, 3, 4, 5 terms. And we have to arrange them in descending order. So just remember, when you are asked to arrange it in descending order, you will just base it from the degree of each terms. Okay, so we'll start with the highest. So which one? This is first term has a degree of 4. Second term has a degree of 3. This one has a degree of 5. This one is just a constant term. So this is 0. And this one is a 2. So there you go. Just arrange it. First is p to the power of 5. Next is 3p to the power of 4. Next would be minus 5p cubed. Then minus 4p squared. And plus 3. Because the degree is 0. So there you go. This is already arranged. This is already arranged in descending order. So most of the time, we will be doing this, especially when we have have problems in algebra. So we will be arranging them in descending order. Okay, let's have another example. So 5p squared minus 6p plus 6p cubed minus 4p minus 2p squared plus 2p cubed. So first, identify the degree of each terms. So the degree here is a 2. Degree here is 1. Again, how did we know that um, these are in different terms? Because of the minus and the plus. So there's a minus here, there's a plus. So this is the next term. Degree is a 3 because it's the exponent of the p. This is just a constant term, so 0. P squared, so degree of 2. Then here, degree of 3. Okay, now, looking at it, there are two same terms with the same degree. So in other words, this is not yet in simplest form. So for now, we're not asked to simplify it. So we can just put them in any order if you want. So perhaps 6p cubed comes first or 2p cubed. It's up to you. As long as they have the same degree, so the order for the two terms would not matter. So next would be 5p squared minus 2p squared. Again, they can be in any order, the two of them, because they have the same degree, 2. Then finally, minus 6p because it has a degree of 1. And then minus 4 because the degree is 0. So there you go. It's already arranged in descending order. So now, if it's arranged in descending order, the first term would have the highest degree. So we call the coefficient, the numerical coefficient, with the term with the highest degree as leading coefficient. So the leading coefficient here is 1 because that's the numerical coefficient of p to the power of 5 with the highest degree. Here, the leading coefficient is a 6. Um, but of course, you might be asking, sir, 6 and 2 are the coefficients of the terms with the highest degree. So to answer that, you can still combine this. So the actual leading coefficient here is not a 6, but that would be 6 plus 2. So the leading coefficient is an 8. Someone will ask you, the leading coefficient is an 8 because 6p cubed plus 2p cubed is 8p cubed. So 8. So how do we define leading coefficient? The term with the highest degree. The numerical coefficient of the term with the highest degree, that's our leading coefficient. So now, how do we determine the degree of the entire polynomial? So what if it's not just a monomial and we're not just simply asked to arrange them in descending order? So as a whole polynomial. So look at this one. So we're asked to identify the degree of this polynomial. So this time, our first example is a trinomial. And our second example is also a trinomial. So according to the given example, the degree here is 4. The degree here is 3. So how do we determine? Okay, very good. That's correct. The term with the highest degree, that's our degree of the polynomial. So in our case here, the degree of this term is 4. The degree here is 2. Degree here is 0. Highest is 4. So that's why it's also 4. Here in our first term, in our second example, the degree here is 2 plus 1. So this is degree of 3. Second term is 1 plus 1, so degree of 2. Third term is 1 plus 2, so 3. So the highest degree is 3, so degree of 3. So this is the degree of the polynomial, the entire polynomial, not just per term. So the degree of polynomial is the highest degree of any of its non-zero terms. So let's have this example. So find the degree of the polynomial. So there are how many terms? So that's these are the minus, the plus, and the plus. So first, second, third term, fourth term. First term, the exponents of x and y, that's 2 and 2. 2 plus 2 is 4. Here, that's 1 plus 5, so 6. Third term, 3 plus 5, 8. Last term, 4 plus 1, 5. So which one is the highest? That's 8. So the degree is 8. So now, why are we talking about degree of a polynomial? Because there's also another way to classify polynomials according to the degree. So what we have discussed previously is how to classify polynomials according to the number of terms. This time, we will classify according to degree. So when the degree of the polynomial is 1, that means it's a linear polynomial. So the highest degree is 1. For example, we have 3x minus 9. So this is degree of 0. The first term is degree of 1. So the highest, if the highest is 1, meaning it's a linear polynomial. If the degree of the polynomial is 2, that means it's a quadratic polynomial. So example, here our first term is 2, second term is 1, and then third term is just a constant term, so 0. So which one is the highest? It's 2. If the highest is 2, the degree of the polynomial is 2, then it's quadratic polynomial. If it's a degree of 3, meaning it's a cubic polynomial. So y cubed plus 2y is a cubic polynomial because the degree of the polynomial is 3 because it's the highest degree of all terms. If it's degree of 4, that's quartic polynomial. So example, this one. 6s to the power 4 minus 3s squared plus 8s. So 4. So quartic, this is a quartic polynomial. And it's quintic polynomial if the degree is 5. So example, this one. So this is a multinomial, obviously, but the highest degree is 5. And if it's more than 5, so we just say it as nth degree polynomial. So allow me to give an example. So for this one, we have 7 as the highest degree because this is degree of 7, degree of 3, degree of 1, degree of 0. 7 is highest, so we call it as 7th degree polynomial. So let's say the degree of the polynomial is 8, so 8th degree polynomial. If it's 10, 10th degree polynomial. Now, this is the last way to classify polynomials, and it's according to the number of variables. So, when the polynomial has one variable, so we can say polynomial in one variable. For example, this one. The only variable involved is s. So, polynomial in one variable because the variable is just s. We say polynomial in two variables if there are two variables involved. So, here, we are involved with x and a y. So, the variables are x and y. So, there are two variables. And if it's more than 2, so we say polynomial in n variables. So for example, we have here 3ab squared c plus 4d minus e. So there are, the variables are A, B, C, D, and E. So there are 5 variables. So we say a polynomial in 5 variables. So if there are 6, polynomial in 6 variables. So we will try to classify each of the polynomial according to the number of terms, the degree, and the number of variables. So we have here x cubed plus 3xy plus 1. So when we deal with number of terms, how many terms do we have? There are 3. What's our degree? The degree is, this is 3, this is 2, this, because that's 1 plus 1, degree of 0. Highest is 3. How many variables do we have? We have x and y, so there are 2. So we call this polynomial as cubic. That's cubic because there are 3. The degree is 3. Trinomial because there are 3 terms. Then there are 2 variables. So cubic trinomial in 2 variables. Let's have B now. X to the power of 4 minus 5. So number of terms, just a minus, so 2 terms. Degree, highest is 4. The variables involved is just an x. So how do we call it now? This is a quartic because the degree is 4. Trinomial because this is not trinomial, it's a binomial. So let me just correct it. This is binomial. So quartic binomial in, it's just an x, so in 1 variable. Next, x plus y plus z plus w. So number of terms, there are 4. Degree, all of them has a degree of 1. So the degree is just a 1. The variables involved are the following. We have x, y, z, and w. So we call this one now, you start from the degree, based from degree, it is just linear. Number of terms, there are 4. So that's multinomial. And then there are 4 variables. So we say linear multinomial in 4 variables.